Welcome to GISD's Tech Bytes, the show that keeps you up to date on the latest technology trends in Garland ISD. I'm your host, Tiffany Vino, and we're kicking off the show at North Garland High School, where students are doing some amazing things with 3D printers. I'm joined by manufacturing teacher Marcus Myers and senior Susie Nguyen. So how are you guys using 3D printers in your classes?
So far, we've been using them for students to do prototypes of designs that they've done in their engineering classes. We've also just done some fun items with them that we've used to repair machinery in our classrooms. And also learning the printers, we've just used some models that we have found online for demonstrating the different types of print qualities. Wasn't designed by our students, but it gives them an idea of how the printer prints in quality. The main classes that have been using these have been our architecture, our engineering classes, and manufacturing classes. The projects that they have done have ranged from their senior projects, which is our final engineering class, or their intro to engineering classes where their final summing up for the year, they actually have to design a train that we can 3D print for them to keep.
So we mentioned senior projects. Susie, you have a helmet in your hand. Tell me about what you're designing.
Yes, this is for bike helmets. What I'm trying to create is a air circulated helmet that first it's just the shell of a helmet. I haven't created the foam of the helmet, which is the main part, and I'm gonna create like a termite way where air can go through and it actually comes onto the head and then comes back out. And during winter it just closes it from cold coming in and actually make our head freezes and give headaches. This right here from the front, this air is going to come through when you bend your head down when you're going forward, and also coming from here, and then there's going to be another hole back here that's going to release the air out.
So tell me, how did you come up with this? Why is this the project that you're doing?
It started in my class, EDD, the seniors take. It's called Engineering Development Design. We have a whole year to come up with a project that and show it to the board of engineers and tell them that this is what we've been doing for the whole year designing. And if they tell us it's already been invented or not, who knows? I mean, there's me and a group of other kids who are doing this, so I'm not alone.
And they do have to search for patents and things to see if it's a problem that's already been solved for their wrap-up. And the engineers that come in and actually grade their project essentially come from the companies that are here in the Garland area, Carly, Garrett Manufacturing, Plastipack, a lot of our different larger manufacturers, along with the Garland Manufacturing Board. So it's not, they're getting real world experience before they head out into, college or into a job.
Do you think you'll see this helmet in stores sometime?
I would like to. I mean, it would be a great thing. I mean, I'm still working on it with this prototype, so who knows.
And so what goes into designing? What type of tools do you use for that?
Tools? Well, we just use this program called Inventor, and we go on there and sketch out the design that you want. And after you design it and modify it, you go on to STL file and have it transferred to MakerSpot, and it will print out from the 3D printer.
So then this 3D printer, Mr. Myers, how does this thing work?
It's actually controlled by the computer. The computer will send a file over that is just a set of coordinates. So it's basically a set of coordinates, and the printer actually uses what's a hot glue gun essentially to control and lay down thin lines of plastic by layers to slowly build up into a complete model that can be articulated, assembled. In the real world, a lot of the 3D printing is now used for prototyping and test fitting parts, whether it be aircraft, automotive abilities, any type of manufacturing, it can be used in now. Our machines are pretty slow. It's not a process that's used for actually making something that would be sold to the public, but for testing ideas and one-off designs, it makes for a really quick and easy way for anyone to manufacture something.
So 3D printing is still a pretty new, exciting field. How is this on the cutting edge and teaching our students something that can help them in the future?
Well, for engineering type classes and manufacturing, a lot of times in these classes, the kids get to learn about it all, but they actually don't necessarily end up with a physical object from what they have done. This allows them to actually take their ideas from, the idea stage, design it, manufacture it, then they can actually test and see whether their designs actually work, whether the parts fit together, whether they interact correctly, if it's supposed to be a rotational part, or if it's supposed to be something that slides together. They can test that before going and having that design made in a metal or a more expensive process. These printers are very cheap to operate. 2 pounds of material is only about $50, and it lasts us months. So the kids really get the whole process instead of just the basics using our printers.
Well, thank you for joining us, Mr. Myers, and Susie as well. While students here at North Garland are learning to design in 3D, students at Couch Elementary School are learning how to do it in Web 2.0. Coding clubs are taking off across the district thanks to a partnership with the University of Texas at Dallas. They're learning through online tools how to animate their own greeting cards and also make their own video games.
Last year we had a lot of new technology come out, and we got really into the hour of code, and I went to some coding training, and we talked about starting up a coding club this year, but we weren't entirely sure how to do it, and we found out that University of Texas at Dallas offered a program where they would send out a graduate student who had great experience in coding and help start teaching our kids how to do coding after school. Our graduate student from UTD, he comes in and he tells us basically what our outcome is going to be. He gives us some tips on what codes can help us to get that outcome, and then the kids have to develop their code on their own. Today what they're doing is they're creating a birthday card today using Scratch, which is a program that was created by MIT, and they have to figure out how to get their card to open when they push the button, and they decorate it however they want to, and basically they have to write the code to make it do that. And we're here just to basically guide them, but they have to figure it out on their own. So it's a lot of higher order thinking skills. They do it themselves.
We use lines of coding, which are instructions to the computer to tell it what to do. So it basically does what you want by lines of coding.
So maybe they have a cat and they want their cat to walk across the screen. So they have to tell the cat to walk across the screen. So they have to choose the right lines of code, like when I click on the flag, then move 100 steps, or things like that. So they have to come up with how it's going to move based on what code they write.
Miss Gooch is really fun, and she's the one who had the whole idea for the program. And so it's really cool that our principal, Miss Hill, let us stay after school on Wednesdays during tutoring.
Our plans are that this is just kind of like our pilot, because it's our first year to have this program, and we're only offering it for 3rd through 5th, but the goal is that in the future we'll be able to have a K2 club and a 3-5 club, maybe even more than one, because we might have a beginner club and then a more advanced club, and then eventually the students will be able to actually write all of their lines of code and be able to create all kinds of computer-generated things, and maybe a future career for them.
We're back at North Garland High School talking about the innovative ways that students here are using 3D printers. This is Sean Denny, the engineering chair, and one of his students, senior Bennett Raymond. So tell me about what you guys are doing.
Well, what we like to do here in a lot of ways is give kids the opportunity to be creative, to be new and innovative. And so a lot of times kids will come in and they'll see something on the internet, or they'll have heard about something and they'll want to be creative. And so we'll use 3D printers and equipment we have in order to give them an opportunity to play a little bit, to see if they can be curious. Kind of like what we were talking about earlier, where when I was a kid, I had a hammer and a screwdriver, and I saw something, I want to put it together. Well, now we're talking high tech. We've got to be able to do electricity and programming and 3D printing and design. And so we get students who just get curious and want to try things and come in and invent. It's pretty cool.
So Raymond, I heard you got curious, and a Game Boy is what you're working on, but a miniature version.
Yes, this is the shell of it. It's about 3 by 2 inches, and it's powered by a Raspberry Pi computer. So when it's fully assembled, it'll have a rechargeable battery, it'll have touch button, everything on there, and a 1.5 inch screen. You'll be able to play games from the original NES to Game Boy Advance games. Almost any older game you can play on this. It's just
so
really
you're
easy.
Basically an inventor. I mean, this is something you've taken a design and a concept like the Game Boy that was out there, but you're creating something totally different.
Right. This is compatible with multiple different systems, and everything inside is, completely different than what you would find in a normal Game Boy. Much more powerful.
So, Mr. Denny, talk more about, how your kids are becoming these inventors and changing the world potentially.
Well, this whole idea of makerspace, being a maker, is that I can go anywhere in the world and walk into a makerspace, and they have similar equipment, and I can look things up that other people have tried and other people have done, and I can create something. I can see if I can do what they've done. It's great even on a bigger scale, because they can actually test professionally what other people have said works. They can become testers and innovators and saying, hey, this does work, or here's your problems, and become professionals even at this level and younger. And so what we're trying to encourage is these kids to come in and realize this stuff is here. It's open for them to play with. It's not only open but encouraged, and they take off. They're as curious as we were, and so they want to know how this stuff works. They want to know how they can print and how they can innovate, and then they come up with ideas that I've never even thought of, and they take it to a whole nother level, and then people around the world get to test what they're doing. So it's a pretty amazing system that we have going on here, and it's really based on the curiosity of the kids.
And so how is the 3D printer kind of changing the game that people can come up, you don't have to buy a Game Boy, you can make your own right here.
Mm-hmm. Well, if you can I borrow that real quick? If you're looking at this and how small this is, it's incredibly tiny. And if I was going to make something, you go back 10, 15 years ago, I would have had to have a whole manufacturing setup to knock this out. I would have had to have tools that I couldn't afford or I couldn't even run. It would have taken a lot of programming. They need now 3D programming and a printer, and they can do things that previously only could be done by big corporations. They can print out anything in the amounts they want and the sizes they want. And so these printers and this technology being in the classroom and being at this size and availability has opened up doors that have just never previously been opened.
Thank you, Bennett, and also Mr. Denny. From 3D printers to coding clubs, technology tools are endless. But what about online safety? The district's Cyberpatriots Club at Rowlett High School is learning how to identify security threats and also finding solutions.
It was during a district PLC 3 years ago that one of the other computer science teachers in the area said, I heard about this new organization, Cyberpatriots, and I don't have time to pursue it, but it might be something that somebody else would be interested in doing. And so I brought that information back to some of my students and talked to our campus technology specialist, and the kids jumped all over it.
We saw the possibilities of this program and where it can go and what it would offer. So we took that, and then we met with UTD, and one of the doctors up there came down and agreed to meet with us and technology. So we basically went to technology and laid out what the program actually is. So we went and looked at all the information from the Air Force Association, got all that background, and then the doctor from UTD came and we met with technology and explained how the program actually works, that we're not really destroying or breaking into the network, we're not going to hack or do anything. Our job is actually to defend it. So they give us a 3-day window. So the competition will start on a Friday morning and end on Sunday evening. So we pick a time when everybody's available and we get together. But once you start, you're locked in for 6 hours. So we'll spend that 6 hours here and compete. And then, so it's every state, every team that's within Texas. And last year it was 728. This year I think it was over 1,200 teams. So we all compete with the same images. So then those teams within the state we'll try to find all the vulnerabilities within that 6 hours. And then once we're done and the window closes, they grade everybody, and then they rate you by how well you've done in number of points and time.
I think the best part is the team members. They're really fun to be around, and they can tease each other, and we work together, and it creates kind of like a bond and like some kind of family.
I enjoy computer stuff, so I get to go hang out with my friends and do computer stuff, and it also teaches you skills for like a real professional career that you could make a living off of.
The kids that would be interested in Cyberpatriots are kids who are interested in learning more about security on the computer, understanding the operating system and how all of that's put together and how it works, not necessarily kids that are just interested in programming. I'd like to see these students mentor students in middle school and elementary school and get some of the programs started there so that by the time they get to high school, they already have a knowledge of the program and we could be even more successful in competition. And then we're blessed to have the ANDCC program that's going to join Rowlett next year. And I've already talked to the 2 Air Force officers that are running that program, and they're very interested in having all service teams. So in addition to having 5 open division teams, we will get to add some all service teams also.
We're wrapping up with architecture teacher Kurt Ortley and sophomore Ryan Scott. So you guys are using the design and the invention and then actually making it real world and tying everything up and coming up with a final product. Kind of tell me about how you use these 3D printers in your class.
So the 3D printers actually function in a multitude of ways. One way is some early investigation. But in this process, we're actually using this to show a completed idea. This is a design for a tower in Chicago. Obviously, we couldn't build a real-life tower in Chicago, so instead we're able to model it in 3D, actually comparing it to the other buildings. The same thing goes for an apartment. So we're actually able to show various components of the interior of the apartment and how this apartment might fit within the context of the tower. We also show a house. So obviously it would be impractical for us to build a house for each student in each design, but with the 3D printer we're able to model it and look at it in 3D, look at the inside. The stairs are actually in here, the TVs are in here, cabinets are in here, everything's in here, so we're actually able to look at the product in its completion.
And so I understand you guys are actually going to take something that you've modeled here and make it a real-life project, a tiny house, and so that's where, Ryan, you have come up with a prototype, and so tell me about your project.
So pretty much Mr. Ortley pitched an idea to us about the concept of a tiny home, which is where you take a full-scale house and put it on a trailer. And so what I've done is I've taken my concept, which is you have a loft, and you put the bed on the loft, and then you have enough room underneath the loft to where you can function as if it were a normal house. And so the 3D printing comes in to where I can actually see this model. So whenever we actually come to build it, this is what it's going to look like.
And so what has being able to 3D print it, how has that helped you? What have you been able to see that maybe you wouldn't have if you didn't have an actual model in front of you?
It allows me to kind of fix like spacing issues. So if, say these cabinets up here, if I didn't like how those were spaced out, I can take this model back to my actual blueprints and I can adjust them to fit how I want them to fit.
And so we can actually build this 3D model in, I think, roughly 8 hours. So within 8 hours, and then there's an 8-hour process, cleaning process. So within 16 hours, sounds like a long time, but within 16 hours, we can actually model a full trailer, tiny house, that will then spend the next semester building. So within 16 hours, we can begin to look at the relationship between the stove, the kitchen, the sinks, the beds. Is there enough space here? Is there enough space there? Do we need to move a window? Do we need to shift a door? We can actually look at that within 16 hours. That's pretty fast comparatively to a year-long building project.
And so coming into this class, Ryan, you knew you were going to be able to use the 3D printer. I mean, was that exciting? And have you been in other classes that, you kind of learn the basics and then now you get to see it come to life? Kind of tell me a little bit about that.
Yeah, being a sophomore, this is kind of my intro to this, but knowing Mr. Ortley and meeting him in 8th grade, one of his big concepts was using the 3D printer, and it really got me really excited about that because it allows me to see my work. And so last year I kind of took a graphic design class where we kind of got into it a little bit, but Mr. Ortley definitely takes it more into depth.
Mr. Ortley, how have 3D printers really changed the way that you teach your classes?
The 3D printing has given me an object by which we can communicate. Even in this discussion here, we've looked at the model, we've pointed to things, we've been able to visualize, we're constantly looking at that as an object. It becomes something that we can then critique. And so it's critical. It takes it from the page, it takes it from the computer, it puts something in our hands that we can point to, we can all agree on, disagree on, but nonetheless have a discussion about.
And so it's taking things like, an apartment, a skyline, a skyscraper in Chicago, things that maybe, you can't really, when you're building them, see the final, scale. And this brings it to something where it's in front of you and you can see it.
Absolutely. It also, it brings in the other classes as well. Geometry. We can look at geometry here in three dimensions. We can look at calculus. We can look at physics. And all of these things become real life in the world of architecture and the 3D model.
Well, thank you guys for joining us. And thank you for watching. That's it for this edition of Tech Bytes. See you next time.